Now I am going to start my finite element lectures, which is related to the beam problem. In the beam problem, this is the governing equations for the beam problem. EI d2 for W by dx square is equal to Q naught. Q naught is the loading, and beam is lie between 0 to L. X varies from 0 to L. This is the beam, general beam, which has been drawn. UDL load, point loading, and this show the displacement, this W, and this show the slope theta dw by dx in the figures. So this is the governing equation. EI dw4 d4 w by dx 4 minus q naught is equal to 0, and use the Galerkin equations. This one EI d4 w by dx 4 minus q naught into weight functions, that is the w dx is equal to 0. From and integrate from 0 to L. 0 to L, EI dw4 by dx4 w dx is equal to w, use the by parts, 0 to L EI dw4 by dx4 dx minus dwx dw by dx EI dq w by dx q dx. This one is the, again use the by parts. This one is the part 1 and part 2, and this equation becomes w EI d2 q by dx q 0 to L minus dw by dx EI d2 square by dx square L minus 0 to L d2 w by dx square EI d2 w by dx square dx. So this one is the w EI dq w by dx q 0 to L, and dw by dx EI d2x by dx square 0 to L. This one is the dwx by dx square EI d2 w by x square dx, and this one is the this is the boundary conditions. This is the w is the essential boundary conditions. This one is the shear force, this one is the slope, and this one is the bending moment, and this gives the stiffness matrix, and is equal to right side. This one is the force matrix 0 to L q naught w dx. Displacement, as we know that displacement and slope, that is the essential boundary conditions, and force and bending moment is the natural boundary conditions. So I will show the natural boundary conditions and essential boundary conditions for simply supported beam. Here at this end and this end, that is the slope is equal to 0, that is the essential boundary conditions. For the cantilever beam, at the cantilever w displacement is 0 and slope is 0, that is the essential boundary conditions. In at this points also the shear force is 0 and bending moment 0, that is the natural boundary conditions. Similarly for this one is the cantilever beam, this is fixed and the shear force applied, force F is applied at this end, so shear force is equal to F. So shear force is considered in the local vector for this simple supported. This one is the fixed beam at the both end, w is equal to 0 dwx by 0, w is equal to 0 dwx by 0, and this one is the general loading which has been applied. So final these equations, k, we know that k stiffness matrix into delta is equal to force plus p. Force is due to the distributed load and p is developed due to the point loading. Suppose moment is m applied on the beam, so all the reactions, moments and point force is the in vectors. So this one is the 0 to L final equations. dw by dx square ei dw d2w by dx square dx is equal to, this one is the force plus boundary conditions. Now analyze the beam. Suppose there is the beam which has the 1, 2, 3, 4 and 5 nodes and 4 elements. Consider a general local coordinate is x, global coordinate is x and local coordinate is denoted by r. That first element is the, suppose constant distance is c from these points. So we can write as x is equal to r plus c. This one is the r and this one is the suppose element which has length L. Wn is the displacement at this point and Wn plus 1 is displacement at this point. Similarly, slope dwn by dx and slope at this point is dwn plus 1 by dx. So for the linear we can write w is equal to c1 plus c2r. We cannot apply the boundary condition. In this case, ei d2 by dx square, that is the bending moment, becomes 0. ei d2 d3 q, w by dx q is equal to shear force, that is the 0. So we cannot use this linear equations. So polynomial use here, polynomial wr is equal to c1 plus c2r plus c3r square plus c4r cube. Wn at r is equal to 0, that is the r is equal to 0, that is the c1, and wn is equal to c1, we can get the constant c1. Similarly, wn plus 1 is equal to w a at the end of the element, that is the c1 plus c2a plus c3a square plus c4a cube, that is the equations 2. And dw by dr is equal to c2. When we differentiate this equation, we can get c2 plus 2c3r plus 3c4r square. dwn by dr is equal to c2 and dwn by dr is equal to c2 plus 2c3a plus 3ca c4a square. This is equations 4. Now dwn, we substitute the value of c1, we can get wn plus 1 is equal to wn plus c2a plus c3a square plus c4a cube. This equation is 5. And dwn by dr is equal to dwn by dr plus 2c3a plus 3c4a square. This equations 6. From equations 5 and 6, we can write wn plus 1 is equal to wn plus dwn by dr a plus c3a square plus c4a cube. This equation 7. And a dwn plus 1 by dr is equal to a dwn by dr plus 2c3a square plus 3c4a cube. This equation 8. And we solve this equation 7 and 8, we can get 2wn plus 1 is equal to 2wn by dra plus 2c3a square plus 2c4a cube. This equation is 9. From equation 8 and 9, when we solve, then you can get this expression a dwn plus 1 by dr minus 2wn plus 1 is equal to a dwn by dr plus c4a cube minus 2wn minus 2wn by dra, and we can get the c4 is equal to 1 by a cube a dwn plus 1 by dr minus 2wn plus 1 plus 2wn plus 2 dwn by dra. This extra line has come through the photostat machines. So this line has no meanings. and C4 is equal to 1 by AQ 2WN plus dWn by dr A minus 2WN plus 1 plus A dWn plus 1 by dr, and again solve it. After solving it, we can get this expression 2 by AQ Wn plus 1 by A square dWn by dr minus 2 by AQ Wn plus 1 by A square dWn plus 1 by dr, and from equation 6 we can get 2C3A is equal to dWn plus 1 by dr minus dWn by dr minus 3 2 by A Wn plus dWn by dr minus 2 by A Wn plus 1 plus dWn plus 1 by dr, and after solving these equations minus 6 by A Wn plus 6 by A Wn plus 1 minus 2 dWn plus 1 by dr minus 4 dWn by dr, and C3 is equal to minus 3 by A square Wn by plus 3 by A square Wn plus 1 minus 1 by A dWn plus 1 by dr minus 2 by A dWn by dr, and we already written Wr is equal to C1 plus C2R plus C3R square plus C4R cube, and substitute all the values of C1, C2, C3 and C4. You can get Wr is equal to Wn 1 minus 3 r square by A square plus 2r cube by AQ plus dWn by dr r minus 2r square by A plus r cube by A square plus Wn plus 1 3r square by A square minus 2r cube by AQ plus dWn plus 1 by dr r cube by A square minus r square by A. So rearrange this one. So Wn within bracket 1 minus 3r square by A square plus 2r cube by AQ plus dWn by dr r minus 2r square by A square plus r cube by A square plus Wn plus 1 3r square by A square minus 2r is q by AQ dWn plus 1 by dr r cube by A square minus r square by A square. So this one is the shape functions, this one is the shape function n1, this one is the shape function n2, this one is the n3, and this one is the n4. So we can write it Wr is equal to n1 Wn plus n2 theta n plus n3 Wn plus 1 plus n4 theta n plus 1, and we can also write in the matrix form n1 n2 n3 n4 Wn theta 1 Wn plus 1 theta n plus